Imagine a world where a single day lasts longer than a year, where the sun rises, stops, goes backward, and rises again, where a 400-degree lead-melting furnace is secretly hiding millions of tons of solid ice. This isn't a sci-fi movie. This is Mercury. Far from being just a dead, boring rock, this entire planet is literally collapsing in on itself, and its bizarre orbit actually proved Albert Einstein right. Let's uncover the secrets of our solar system's most extreme world. To understand why Mercury is so vital to science, we have to travel back to the 19th century. At that time, Isaac Newton's laws of gravity were considered absolute truth. They had perfectly predicted the movements of every planet, even leading to the discovery of Neptune. But Mercury was different. Astronomers noticed that its orbit was shifting, or precessing, by a tiny, unexplainable amount, just 43 arcseconds per century. The leading mathematician of the era, Urbain Le Verrier, who had correctly predicted Neptune's position using math alone, was convinced there must be another hidden planet. He called it Vulcan, named after the Roman god of fire. He believed Vulcan was hiding in the sun's blinding glare, tugging on Mercury with its gravity. For decades, astronomers claimed to have seen it, but it was never officially confirmed. The mystery remained until 1915, when Albert Einstein published his theory of general relativity. Einstein proposed that gravity wasn't just an invisible pull, but a curvature in the fabric of space-time itself. Because Mercury sits so deep in the gravity well of the sun, the space around it is heavily warped. When Einstein applied his new equations to Mercury's orbit, they predicted the 43 arc-second shift perfectly. Mercury became the first great proof that our reality is far stranger than Newton ever imagined, rendering the phantom planet Vulcan unnecessary. What makes Mercury so extreme starts on the inside. If you were to cut Mercury in half, you would find something unlike any other planet. While Earth has a relatively small core compared to its size, Mercury is essentially a giant metallic ball covered by a very thin rocky shell. Its iron core is roughly 3,600 kilometers wide, taking up nearly 85% of the planet's total volume. This high iron content makes Mercury the second densest planet in the solar system. But why is it so unbalanced? Most scientists believe Mercury didn't start out this way. The giant impact hypothesis suggests that early in its history, a massive protoplanet, perhaps half the size of Mercury today, crashed into it. This cataclysmic event would have stripped away most of the original rocky mantle and crust, leaving behind the massive iron core and just a thin layer of rock. This unusual, thin-skinned anatomy set the stage for the planet's most dramatic geological feature, its ongoing contraction. Because Mercury's rocky mantle and crust are so thin, they act as very poor insulation. Since its birth 4.5 billion years ago, Mercury has been leaking its internal heat into the vacuum of space. As the massive iron core cools, it slowly turns from liquid to solid, and as it does, it occupies less space. This causes the entire planet to contract. Since the outer crust is cold and rigid, it cannot just shrink like a balloon. It has to break. This process creates what geologists call Lobate Scarps, massive, winding cliffs that resemble the wrinkles on a dried-out fruit. Some of these cliffs, like Discovery Rupes, tower 2 kilometers high and stretch for hundreds of kilometers. In 2016, researchers using messenger data discovered something even more grand, the Great Valley. This is a colossal depression over 400 kilometers wide and 1,000 kilometers long. It is deeper and longer than the Grand Canyon, formed as the planet's shrinking interior forced the crust to buckle and collapse. Recent studies suggest that because some of these faults look fresh and uncratered, Mercury is likely still shrinking today. Mercury's rotation is one of the most confusing things in astronomy. For a long time, we thought one side of Mercury always faced the Sun, just like one side of the Moon always faces Earth. But radar observations in the 1960s proved otherwise. Mercury is locked in a 3-to-2 spin-orbit resonance. This means it rotates on its axis exactly 3 times for every 2 orbits it makes around the Sun. This creates a truly bizarre calendar. Mercury's year is only 88 Earth days, but its sidereal day, 1 rotation, takes 59 Earth days. However, because the planet is moving so fast along its orbit while rotating so slowly, the time from one noon to the next, a full solar day, takes a staggering 176 Earth days. That's right, 1 day on Mercury is twice as long as its year. If you were on the surface, you would witness the double sunrise. Because Mercury's orbit is very elliptical, its orbital speed changes. At certain points, Mercury moves along its orbit faster than it rotates. This causes the Sun to appear to stop in the sky, move backward for several Earth days, and then continue forward again. It's a place where the Sun literally changes its mind about where it's going. Mercury is a world of impossible contradictions. Daytime temperatures soar to 430 degrees Celsius, hot enough to melt lead. But because Mercury has no atmosphere to trap heat, the nighttime temperatures plummet to minus 180 degrees. But the biggest surprise is at the poles. There are deep craters like Prokofiev and Kandinsky, whose floors have been in total shadow for billions of years. In these permanently shadowed regions, the Sun never rises above the crater rim. Using radar, NASA's Messenger spacecraft discovered millions of tons of water ice hiding in these dark pits. It is a haunting thought. Frozen, prehistoric ice surviving for eons, just a stone's throw away from a sun-scorched wasteland. And that's not the only mystery on the surface. Messenger also found hollows, strange, bright, shallow depressions that look like someone took a giant ice cream scoop to the surface. These hollows appear to be fresh, suggesting that some minerals are literally turning into gas and evaporating into space even now, meaning Mercury is still a geologically active and changing world. Our journey to understand this tiny titan is far from over. Currently, a joint mission between Europe and Japan called Bepi Colombo is zooming through the inner solar system. It is the most advanced mission ever sent to the first planet. By late 2026, it will arrive and deploy 2 separate orbiters to study Mercury with unprecedented detail. Bepi Colombo will use high-tech lasers and sensors to map those shrinking faults, measure the massive core, and finally solve the mystery of why Mercury even has a magnetic field, something it shouldn't have for its size. We are about to see Mercury in a way we never have before, peeling back the layers of a planet that continues to defy our expectations. Mercury teaches us that size isn't everything. This tiny, shriveled world proved Einstein's theories, survived a planet-shattering impact, and hides ice in a sea of fire. It is a dynamic, evolving laboratory that holds the keys to understanding how all rocky planets, including our own, were born, and how they will eventually cool. What part of Mercury's story is the most mind-blowing to you? The double sunrise, or the fact that it's literally shrinking? Let us know in the comments below. If you enjoyed this cosmic journey, hit the like button and subscribe for more deep dives into the wonders of our universe. Stay curious and stay with science.